Alright, welcome back to the slides on loops. We talked about last time both while loops and for loops, and how to get into trouble with them. And now I want to talk about the finer details of stuff that you can do inside of loops. Okay, I want to talk about two new keywords called continue and break. Alright, so these keywords, these are just lines of code. You can say continue semicolon and break semicolon. They only work when you're inside of a loop. Okay, it's only valid to use them inside of a loop, and here's what they do. If you say continue when you're inside of a loop, that skips a loop iteration of the body. So it goes straight to the end of the body and right back to the top of the loop to start a new iteration. Okay, so let me show you continue now in a for loop. Let's pretend that we don't like the number 3, but we're like iterating through 1 to 10 or something. So let's see out vim, let's just call it continue. Continue break. Continue and break.cpp. That's useful enough. So here's a for loop. Let's go from 1 to 10 as usual. And let's print I. So right now that's going to print just normally 1 to 10, right? But we can use continue to skip an iteration of the loop. We can be like, I don't like the number 3, so let's just not print 3, but we'll do everything else. Okay, you see that would be hard to do otherwise without this thing called continue. So if I was about to print my 3, if I is equal to 3, then let's just continue. Skip the rest of this loop body. Another way of saying that is the rest of this loop iteration. Okay. So now, the second we see that I is 3, we're going to continue, which goes straight to the end of the loop, and does everything else that needs to be done, like increment, and then it goes back to the condition, and then pretends that iteration never happened. So we skip out on the 3. See that? Goes 1, 2, 4. So that's continue. It's just a keyword that you put on a line all by itself with a semicolon. So continue is that. And then break is probably the more common of the two. That one exits the loop. It finishes off the loop. That would have otherwise maybe have continued forever, or that would have exited later after something else had happened. But we're finishing it sooner than later. Okay, so break stops a loop. Stops the closest loop that you're in, because you might have a loop within a loop. It stops the closest one. Okay, that it has that is closest to it, I want to say. Okay, so let me show you a demo of that. Let me give you a while loop and have it stop when the user types Q. Okay, so that's what I want to do here. So let's make a while loop. I don't know, while true or something. This is normally an infinite loop, right? This would normally be an infinite loop. But we can stop it with break. So, I don't know, char C. Let's get it from the user. Dun, dun, dun. So, I don't know, let's just play around with the user. Let's say if C is equal to Q, then we wanted to quit, right? So we wanted to stop the loop break. And then else we could be like, I don't know, C out U typed, and then whatever the C was. It wasn't Q. I guess that is something useful. It's my contrived example. But this is normally, it would have been an infinite loop. It would have continued forever, kept asking the user until the end of time, but we can break early. We can stop the loop with a break if something special happened, for example. Okay? Oops. What have I done wrong? I never use cn, sorry. That's useful. There we go. So enter a character C. I don't know. SCI 40. Yay. And then Q. And that stops the loop because it finally found the Q and it breaks. Break stops the loop. Okay, does that make sense? So continue and break, they are your friends. More often, it's break that you care about. Continue is very rarely used, but I think you can see the use of it. So those are my two examples there. And now let's do something fancy. Let's calculate e, guys. Won't that be fun? So we'll calculate the number e using a loop. Well, let's do it. So if you remember from like calculus class, e can be found using an infinite series, like some sort of Taylor expansion, I think, right? So e is precisely equal to this sum on and on forever, right? 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, on and on forever. Compactly, it's written like this. This is like a mathematical loop. It's 1 over n factorial as n ranges between 0 and infinity. So first add this, then add this, then add this, and just let n be 0, let n be 1, let n be 2. And that's kind of how we can make our loop work. Okay, we can make a variable called n, and it can keep track of which term we're working on. Like we want to first start with this one. We'll calculate this term in one iteration of the loop, add it into our e variable. We'll calculate this term in the next iteration of the loop, add it into our e variable. So we're just going to keep on doing that and sum them all together. So like sum is a variable, it can start at 0, and then we keep on adding in the current term of our infinite sequence. So we'll make a variable called current term, and that'll start out at like, or it'll always be 1.0 over factorial of n, and we'll just keep on adding that into sum. Do it enough times, we'll get close to e, right? So we don't need infinite precision. We don't need to add until the end of time, because doubles can't hold infinitely precise numbers anyway. They only get like 16 digits of precision. Let's just go between the terms, this one and like 1 over 100 factorial. Like, let's do this. Let's go up to n, or let's go from n equals 0 to n equals 100. Okay, so we'll loop from 0 to 100 and calculate just those terms, the first 101 terms, because 1 over 100 factorial is the world's tiniest number anyway. That's not really going to add to the final answer. We're going to get a very precise value of e, even maybe just going up to like 10 or something. So we'll just overkill it and go to 100, but that's the plan. So a bunch of iterations of the loop to compute the term of this sequence, this series, and then we add it into the sum variable, and then once we've done 101 of them, our sum variable is going to look a lot like e. Okay, it's going to be a great approximation for e, if not perfectly precise within a double. Okay, so in order to calculate all this, I need a factorial function, which is not in the C++ standard library, so I'm going to write one. Don't tell anybody. We haven't learned about how to make our own functions yet, but you're just going to have to watch me for a second do it. But one important thing that I have to do for this function that I don't want to forget is to make sure that it returns a double, because 100 factorial cannot fit in an integer. It can in a double. So that's how that's going to work. So vim e.cpp. So what I would like to do is this. I'd like to start my sum at 0, and then I want to repeatedly calculate each of these individual terms as long as n is between 0 and 100. I want to keep on calculating 1 over n factorial and add it into sum. Okay, so while, let's do a for loop. For int n equals 0, n is less than or equal to 100, n plus plus, so n is going to range between 0 and 100 inclusive. And then we want to add into sum the current term. So double current term is equal to 1.0 over factorial of just whatever n is. And then we will add that into sum. Remember that the plus equals is the same as sum equals sum plus current term. We add it into sum like that. And then after we get out here, we can output the sum variable. It's going to be a very good approximation for e by then, okay? With enough terms, with 101 terms. So that's the plan. All that's missing is a factorial function, and let me go and write one now. So look away if you'd like, but this is what it needs to do. It needs to return a double for size reasons, but it takes an int, and I don't know, let's say double result equals 1.0, return result. The factorial of 0 is defined to be 0, by the way, so that's important here. Sorry, it's defined to be 1. 0 factorial is defined to be 1. Same with 1 factorial, also 1. So let's make a loop that doesn't run if n is 0. For int I equals 1, I is less than or equal to n, so if n happened to be 0, this would never even happen. N plus plus, and then I'll be like result equals result times I. So I'll multiply them all in kind of backwards for a factorial. Okay, and return that result. I think that'll do it. Let's take a look. Whee! Did I save this properly? It looks like I have an infinite loop. Excuse me. Oh, sorry, n plus plus. It was supposed to be I plus plus. See, that's what happens if you don't test your code. But that's the correct factorial, and this unassuming little loop just precisely calculated e for us. Isn't that so cool? So yeah, that is some cool stuff that you can do with loops. Isn't that nice? So the next thing that I'd like you to try is just, I would like, obviously we're not in class right now, so you can't like write your answer in the Google Doc. You can if you want, go for it, pick a spot on the class website. But I want you to think and maybe try on your own to find a few examples of an infinite loop, okay? And make them extra subtle too. Don't make them obviously infinite loops, okay? So think about that, and I think that's a really, really good exercise. Think of how you can do things wrong, and that will help you avoid doing things wrong, all right? So let me come up with my one good example of an infinite loop. Let's try, I don't know. What would happen if I did something like this, right? If I wanted to print from 1 to 10, but I did something like this wrong. I didn't say I is less than or equal to 10. I said I is, I don't know, greater than or equal to 1. I plus plus. C out I. You see why this wouldn't work? The condition is wrong. It's like, this is always going to be true. I starts at 1, it's always getting bigger. So that's never going to get to 10 and stop. Okay, so that's another subtle example of an infinite loop. I'm sure you can think of some cooler ones, and I encourage you to try, even for a while loop, as well as for a for loop. Okay, so that's a good example, I think. And before I get into this very fancy topic called nested loops, I want to just show you another fun example. Before then, let's animate things using loops. So remember that pause function that stops the program for a little bit that I used in our karaoke example on the first day of class? I'm going to steal that and reuse it, and let's make a cute little animated line of stars. Alright, so we can use loops for animation. So we can like print a star, wait a little bit, print another star, wait a little bit, print a third star, wait a little bit, things like that. And so it'll look like it's falling, or it's like becoming a very long pile of snow or something. So, but that printing and waiting can be used to make animations as well as make a karaoke program. Okay? So let me show you that. I don't know. Animation.cpp. So I want to steal that pause function from the first lecture. Don't worry about like remembering how to implement this. This is just something I had to look up, so not a big deal. Pauses for a certain number of seconds, and now, oops, I would like to use that to print, like, I don't know, let's use a while loop this time, because why not? Let's print, I don't know, 10 rows of stars. So I'll print a single star, and then I'll wait for a little bit. Pause, like, I don't know, 0.2 seconds or something. And so it'll print, wait a little bit, and then continue this loop as usual 10 times. But that pausing is magical. It won't immediately draw a million stars. It will wait And I encourage you to write a fancier program than this. But this is just an example of what could be done. Look at it go. And maybe that's too long. Maybe it should have been paused for half a second. Or it was too short. Look at it print things. Look at it go. Isn't that fun? So that is an example of animation. And you can do cooler stuff with that. You could like make it print a triangle that's leaning over, things like that. But it's all in the pause. Okay? So have fun with that. Play around with it. Maybe randomly pause for a random amount of time. Cool stuff. Okay, so that's just another example of a loop. Just a quick one. And now I want to get into something called nested loops. Okay? That's where you put loops inside of loops. Unfortunately, that's a thing that is very common and necessary to understand. It is also, unfortunately, a very difficult concept historically for students in this class. Okay? It's just one of those things I'm required to teach you, but it's one of the harder things. So maybe pay a little bit extra attention this time. Okay? So, let us begin. Nested loops. Just like when you have a bunch of if statements nested together, you can have a bunch of while loops or for loops nested together. That's not a problem at all. And what I want to get across is that the body of the outer while loop here just treats this inner while loop as code. So it's like one big thing with a semicolon. Think of it that way, okay? That's my best drawing of a semicolon. That's large. So every time this while loop, its condition is true and it executes its body, it's got to run this entire inner while loop, right? During each iteration of the outer loop's body, the inner loop executes completely. That's the key idea here. So if this while loop is taking I between like 1, 2, 3, 4, all the different times, and this while loop is taking j from 1, 2, 3, 4, all the different times, when I is 1, j goes through all of its values, and then it gets a chance at having I being 2, okay? Then I is 2, and j gets to go through all of its values all over again, because this inner while loop is just code as far as, it's just one big long line of code as far as the outer loop is concerned, okay? I have examples that will make that make more sense, but really, this is just one big thing with a semicolon. It runs completely. It's the body, okay? So here is my best initial example of a nested loop. Okay, it's for loops. It's doing exactly what I was talking about. So it's taking I between 0 to 4, and it's taking j between 0 to 4. Okay? So think of it this way. This loop is going to execute its body exactly 5 times, right? Because I goes between 0 and 4 inclusive. So this executes its body 5 times, and each of those 5 times it runs what's inside of it, which just so happens to be another loop. Okay? This also executes its body 5 times. We also executes body 5 times. Okay? And the one real piece of code that's being run inside of any of the bodies, inside of the innermost body, is this one, printing I space j. Okay? So that's what's happening. And as far as this outer loop is concerned, this inner loop is just a piece of code. It's going to run it completely before it goes back and runs the next iteration of its outer loop. So this is going to print, when you run it, all this stuff over here. It's going to print 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then it's going to go 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And I want to show you why that's going to happen, okay? Let me walk through this code just with some boxes. So when this loop begins, because it's the first loop, it sets I to be 0, okay? And then it's going to run its body as long as the condition is true. Well, yeah, 0 is less than 5. Let's go. So it runs this entire body, which is itself a loop, okay? So that is important. So now it's our turn to run this loop completely, all right? And it's going to execute its body 5 times. So it starts its j at 0, its initialization, and then it's going to run its body as long as j is less than 5. Yeah, 0 is less than 5, so let's run that body once. So it's going to print 0, 0, because I is 0 and j is 0. That's the first line. Okay? Then, remember, this loop needs to finish before we ever get to the end of it down here and go back to the outer loop. So, j++, j is now 1. Then, 1 is still less than 5. We're going to print I space j. And notice that I never changed. I is still set to 0, because we haven't ever worried about this increment yet, because that would involve this entire body being finished, and we haven't finished it yet. Okay, so it's going to print 0, 1. And likewise, it'll keep on incrementing this j variable. 1, 2, 3, all the way until 4. I guess 5 as well. But it's going to print 0, 1, 0, 2, 0, 3, 0, 4 without touching I. Do you see that? And then j is 5, and this is now false, and so it skips over, is done with this inner loop. Okay? It has completed one one iteration of the outer loop, okay? Because now we've run everything inside and we're ready to, it's like we were right here ready to run more code. There isn't any more code. So we've hit the end of the outer loop. We're ready to go back to the start of it to see if there's more to do, okay? The second we plop out of this loop, remember scoping, j ceases to exist. So j's gone again now. And now we go back to the outer loop, okay? Please yell at me in office hours if this does not make enough sense. This is important stuff, okay? It is hard to wrap your mind around, I know. So we're back out here. I++, I becomes 1. Hey, hey. And then 1 is less than 5, so we're going to run this entire body all over again, which is going to take its j between 0 and 4 all over again. You see that? So j is 0 again. It's going to run this entire loop. J goes between 0, 1, 2, 3, and 4, and it's going to print. When j is first 0, it's going to print ij again, but now I is 1. 1, it's going to print 1, 0. 1, 1, 1, 2, 1, 3, 1, 4. All these. And then it's done with this inner loop, ready to do the outer loop one more iteration. I++. Now I gets to be 2. Do the inner loop. Now I gets to be 3. Do the inner loop. Do you see how it's working? That is what I want to get across to you, okay? Something that you can think about and notice, that I want you to notice, is this line in particular is going to get executed 5 times 5 times. This executes 5 times, this executes 5 times. So this line here gets executed, and that's going to be important later. 5 times 5 equals 25 times exactly. Okay? And it's also kind of shuffling through all the different pairs of values of I and j. Everybody is included. I goes between 0 and 4, j goes between 0 and 4. These are all the different possibilities of I and j when they are allowed to range like that. Okay? So those are the two magical features of nested loops. The first is that nested loops multiply work. So if you want to draw 16 stars, you can have a nested loop that's drawing a few stars at a time, maybe a line at a time, okay? One loop goes 4 times, the another loop goes 4 times, and now suddenly you've drawn 16 things, okay? Nested loops multiply work. That's the first bit. So let's do that to draw a box of stars. So here is the output we're going to make in our next program that we're going to write, and let me show you the strategy. So let's draw a box of stars this way. Let's work on each individual line at a time. Okay, each individual line at a time. So the we'll have the outer loop, and this will become more apparent when I write the code. The outer loop will worry about which line we're on. It just needs to worry about repetition, because essentially we want to repeat, draw a line of 4 stars 4 times. You see that? And so the outer loop will worry about the line, and then the inner loop, each time we're on a different line, that loop will worry about drawing 4 stars, printing a line of stars. Okay? And so, let me write kind of not C++ yet, but closer to C++, what needs to happen. So 4 times we need to draw a line of stars, okay? So do 4 times the following. Print 4 stars and a new line. Okay, that's what needs to happen. So this is the outer loop, and printing 4 stars can be done with another loop inside of a loop. You see how I'm breaking that down? It just kind of naturally becomes a nested loop. You see that? So this inner loop, we can translate that into this kind of style. We can say, okay, do 4 times. Let me give myself some more room. Do 4 times. How does this translate into code? Print 4 stars and a new line. Well, that's do 4 times. Print a single star, right? See how that's working? There's the inner loop. And then after you've printed all your stars 4 times, then print a new line. And then you can just go right back and repeat this whole thing 4 times. You see that? So this is what we can translate to code. So that kind of goes like that. So let me show you this. Let's make a box. All right, so what I want to do is, okay, I need to do something 4 times. Notice I'm not using any variables anywhere. I just need to have a loop that iterates 4 times. I can use I for that. Usually you start your loops at 0 when you're just iterating a certain number of times. So I is less than 4, we'll iterate 4 times. I goes between 0 and 3, but we're never going to use I for anything other than counting which line we're on. Okay, so this loop worries about what line we're on. Oops. And then inside of that, we're going to do our do 4 times, print a star. So that is 4 int j equals 0. J is less than 4. J++. That'll execute the loop 4 times, its body. This is just print a single star. See how it's star character. And then, so this will print 4 stars. And then we want to print a new line. Right? I could have also used endl. But this is, okay, 4 times, do the following, which involves printing 4 stars, and then printing a new line. You see how that kind of just falls out of what we were required to do? It just works. And look at our pretty box. Look at it go. So definitely study this code, understand how I went from this to the C++, and then I would like you to try. Okay, so here is my original code. Take that, look at it, and see if you can figure out how to transform it from drawing a box of 4 stars to a hollow box of 4 stars. Okay? So think about that. And then I'll come back and show you my strategy. Okay, so the most important thing to think about, I would say, is where we are when we want to draw a space versus where we are when we want to draw a star. Okay, so when we want to draw a star, like, what are all the values? So this is the I equals 0 line. I equals 0, and when we draw this star, j equals 0, j equals 1, j equals 2, j equals 3. See that? So those are how those 4 stars get drawn. And then on this line, something new must happen, right? I is 1, and now suddenly, when j is also 1, we should print a space instead of a normal star. See that? Interesting. So that's what needs to happen there. We need to notice when we're here, and instead of printing a star for these pieces, we better print a space instead. So what is true about these? Okay? That's where we go to an if statement. So we could say something like, when I, this is I equal 2, I equal 3, when I is between 1 and 2, and j is also between 1 and 2, then we're in the middle here. And in that case, we want to print a space. Okay? So you can translate the code like this. If I is greater than or equal to 1, one thing you can't do in C++ is this. 1 less than or equal to I less than or equal to 2. I wish you could. You can do this in Python, but this is not allowed. You have to transform it into this and this. Okay, so if I is greater than or equal to 1 and I is less than or equal to 2, so that covers I is between 1 and 2. And then we also want to pick out when j is between 1 and 2, only when those are all lining up like that. So j must also be between 1 and 2. J is less than or equal to 2. If we are in this case, then we want to print a space. Otherwise, that's when the star gets printed. You see that? That's how you do it. That's the trick. Did you get it? So let me show you this. Let's have a new line just to spice things up. Have a space. And then this one, let me delete the comments because that might get confusing as I'm changing everything. Okay, so instead of printing always a star in here, we want to sometimes print a space, sometimes print a star. So if I is less than or equal to 1, greater than or equal to 1, and I is less than or equal to 2, and j is greater than or equal to 1, and j is less than or equal to 2, only when all that is true, then print a space. Otherwise, that's when the star must appear. Okay? That's how you do it. And there is our hollow box. Does that make sense? We're just sectioning off when we want a space versus when we want a star. It's very similar to the starting code, though. We kept all those i's and j's everywhere. Notice I'm never like printing I, printing j. I'm just using that to keep track of what line I'm on and what column I'm on. Okay? All right. Another example. Let me show you how to draw a triangle instead of a box. Let's draw a left-leaning right triangle. Okay? We can do that using nested loops. The strategy is usually always the same when you're drawing something. It's like your outer loop controls what line you're on. So like this is I equals 0 line, this is the I equals 1 line, I equals 2 line, I equals 3 line. And then, depending on what line you're on, you have to draw a different number of stars this time. It's not always 4. It's what? Can you figure out the relationship between what line you're on and how many stars you draw? Because we want to do the same thing inside of an inner loop. So the trick is, if you notice it, if you think long enough, on every line you want to always draw how many stars? It's always I plus 1. On this line you want to draw 1 star. That's 0 plus 1. On this line you want to draw still I plus 1. Because I is 1 here, I want to draw 2 stars. And that's how you do it. Okay? So let me translate that to code, and let's see how cool it looks. So I'll take this starter code again, I guess. How do I want to do this? Triangle.cpp. So let me take the normal box. Here's the box printing code. And then I want to print not 4 stars, but I plus 1 stars each time, okay? So I need to make sure that this loop iterates not exactly 4 times, but always I plus 1 times. So you see what I must change. So if I want a loop to iterate exactly 4 times, I just do it like this with this pattern and put a 4 here. So this is also iterating 4 times right now. I just got to mess with this to change how many times it prints. Okay, so if I want this to go I plus 1 times, I can just change this to I plus 1. Okay, isn't that nice? That's the pattern there. And so that's all I have to change. This loop is now going to depend on I. It's going to print a different number of stars depending on what I is, because that's controlling how many times this inner loop executes. Isn't that nice? Oops, let's compile the right program. Whee! And so we have a left-leaning right triangle. Isn't that nice? That is pretty. So the key difference was we used this I variable finally to control how many times the inner loop executes. That's how we print our I plus 1 stars. Okay? And then that was us taking advantage of the fact that we learned how nested loops multiply work. Okay? They multiply work together. That was the first key idea. The second key idea is that nested loops try all the possible combinations of values. Because you see here that when we allow I and j to range like this, they're going to go over every possible combination of I and j, of 1 to 4 for each of them, right? So that's another thing that nested loops give you. They let you try all the possibilities, all the different combinations of values, okay? And one way to exploit that is to write what's called a brute force algorithm, okay? That is an algorithm that just tries every single possibility for a problem to see if it can find a solution, okay? And a lot of the time, if you have a small enough problem, this is doable. Like, your computer is pretty fast. It can do a few billion operations a second, so it can try all the possibilities pretty quickly if there's not too many. All right, so here's the problem that we're going to solve with a brute force solution using a bunch of nested loops to try all the possibilities. Okay, so here's the cute problem. We are a farmer, and horses cost $10, pigs cost $3, and rabbits are on sale today. They're only 50 cents. So a farmer, I guess somebody else, a farmer goes and buys 100 animals for $100. Our friends told us this or something. But we're not sure which animals they bought. How many horses, how many pigs, how many rabbits did they actually buy? Okay, the farmer bought 100 animals for $100. How many of each animal did she buy? Okay, so we're not sure if maybe she bought entirely horses. So let's try all the different possibilities of all the different ways you could buy 100 animals. Okay, watch this. So we're going to let 3 variables range between 0 and 100, because maybe you bought all horses or all pigs or all rabbits, though we know that's never going to work out. So let's keep track of num horses and num pigs, and we're going to let them try all the possibilities, and num rabbits. Okay, so we're going to have all these variables, and they're all going to be allowed to range between 0 and 100. We're going to let them try all those possibilities between 0 and 100, 0 and 100, 0 and 100. And so, this is going to be a triply nested for loop, right? That's what we're going to need. Triply nested loop to try all combinations of all these 3 different numbers. Num pigs, num horses, num rabbits. Okay? So let's set that up, and then we'll try and solve the problem based on that. Okay, so, I don't know, what do I want to call this brute force? So, we have for int num horses equals, the farmer could have bought 0 horses, or the farmer could have bought 100 horses. Num horses less than or equal to 100, num horses plus plus. Okay, so we're going to just let that number range to be all of those possibilities. So that's the first one. Then we have pigs. Pigs can range between 0 and 100. Oops. So that's possible. Then we also have rabbits, could range between 0 and 100 as well. So that's another inner loop. Whee! Isn't that nice? So that is my triply nested for loop. When I'm in here, each time I get here, I have a different possibility. I'm going to try each possibility of num horses, num pigs, and num rabbits, okay? Okay, so maybe I'm in the loop, and here, like, num horses is 10, num pigs is 20, and num rabbits is 100. It's going to try all those different possibilities between 0 and 100 for each of them. Okay, so this is going to iterate 100 times 100 times 100 times, and it's going to run this inner code 100 times 100 times 100 times. Isn't that interesting? So I have a value for num horses, num pigs, and num rabbits when I'm in here, when I'm in the innermost loop. Okay, so now I need to see if that amount of horses, pigs, and rabbits solves the problem. Let's see if this amount of horses, pigs, / rabbits solves the problem, because I'm going to have a different amount each time. I'll start with the possibility of 0 horses, 0 pigs, and 0 rabbits. That doesn't work. I have to have bought 100 animals for $100 to solve the problem. Okay? So let's calculate, when we're in here, how many animals did we buy? Num animals total is, well, num horses plus num pigs plus num rabbits. So we're trying all the possibilities. It doesn't have to add up to 100. So that's how many animals that we bought in this particular iteration, how many we're considering. We're trying all those different possibilities between 1 and 100. So it's possible that this num animals is equal to 300 and it doesn't solve the problem. So we've got to check that. So that's num animals. And then we also need price. That is, each horse is $10, each pig is $3, and each rabbit is 50 cents. So let's multiply. Horses times 10 plus num pigs times 3, right, plus num rabbits times 50 cents. Yeah? And the order of operations will make sure that this all works out right. So I bought this many animals for this price, and I solved the problem if num animals is equal to 100. I bought exactly 100 animals, and the price is equal to 100.0. Yay. This is one of those cases of like, do as I say, not as I do. You're not really supposed to check if doubles are exactly equal to 100, but it will work out in this particular case. Okay? So, let's see. Let's run this program and see if we got inside of this if statement. If so, see out the number of horses, the number of pigs, and the number of rabbits. New line. That should do it. So need a space there. Let's make this slightly prettier. There. Okay. So if we ever get here, then we solve the problem. Our combination of horses, pigs, and rabbits in this inner for loop finally gave us what we were looking for. If so, let's print out the solution that we found. And see how this is working. It's trying all the possibilities and seeing which ones solve the original problem. Yay, there it goes. So it looks like there are 2 solutions to this problem. Either, let me scroll back up here so you can see the code as well. Whee. So there it is. There. Perfect. So it looks like in the case where I bought 0 horses, 20 pigs, and 80 rabbits, it's exactly 100 animals, yes, and it's exactly $100 too. And if I bought 5 horses, 1 pig, and 94 rabbits, that's a weird one, but that also solves the problem. Those are the only 2 ways of buying 100 animals and spending exactly $100. Okay? Isn't that cute? So we can always confirm this. Like, we know that these add up to 100, so that's the first part. But you can be like, okay, let's check our solution. It's 5 horses, that's 5 times 10. 1 pig, that's 1 times 3. And 94 rabbits times 50 cents. Oh man, that's 100. Nice. Cool. So yeah, that's one nice thing that nested loops are for. You can try all the different possibilities of a different range of numbers. Okay? A huge, long range of numbers. As many as you need. Okay? It's trying all those different possibilities. But this one is 3 numbers that we're trying all the possibilities of, rather than just 2. Okay? So that is my last major example for the lecture today. And then the next thing that I want to show you is just one last thing about translating this to that flowchart form, because that's a great way to understand how these loops are executing. Okay? So let's translate this program to a diagram. Okay? So you got before. That's going to happen first. And then let's figure out like what's going to go where. How does A lead to B, C, D, and E, and after, and all that. Okay? So let's talk about it. So a while loop always executes the condition first and continues with the body as long as that condition is true. It keeps on looping. Okay, so the first thing that's going to happen in this program is it's going to check A and see if it was true or false. So if it's true, we continue. If it's false, then we're done with all of this entire thing. It skips the whole while loop, including the inner bit, and goes straight to after. So after is down here. Okay, so that's like that. And then, if it was true though, we try and we run the entire for loop, which is going to initialize itself with B. Then it's going to repeatedly check its condition, run its body, and run its increment statement as long as that condition remains true. Okay, does that make sense? So then we first check C, that's the condition. Then if it's true, we are going to execute the body of that loop, E, and then the increment statement always happens after it before we go and check the condition again. So that's D back to the condition. Okay, so that we'll repeat that just like that if that ever happens. It's always true. And then eventually C might become false, in which case we are done with the inner loop, which means we need to go back and try and continue the outer loop. So we go back to test A if it's false. You see how that's working? So that is the flowchart diagram, and this is supposed to say false here. Definitely yell at me, and if this is not making enough sense, this is important to know how all these different loops are going to execute and how they're going to execute together, okay? So that's what I want you to be able to do. And then finally, I have a cute little example that my boss sent me. This is a nice pictorial example of a nested loop, right? If you want 9 options, you can have 3 things being done in an inner loop and 3 things being done in an outer loop. Combine them together and suddenly you have 9 different things. Isn't that cute? So I think that's fun. And that is officially all that I want to talk about for loops today. Okay, the next thing that I want to do is, next week we'll continue with these. We have 2 extra slides. We'll get to those then. But the final thing that I want to do is talk about your midterm, because you have a test coming up soon. So it's week 6, like promised, and I've made a midterm 1 module for you to look at. I'll right now release the midterm 1 info page and the extra credit assignment page. All right, so let's go and look at both of those. So info page first. The midterm 1 will be available week 6. I will make it available on 5:30 p.m. the Thursday. Oh, sorry, that's a Wednesday. Excuse me. The 16th is a Wednesday, and it's going to be available until 5:30 p.m. on the 17th, Thursday. Okay? So that is the 24-hour range in which you get to take the exam. So pick a time period and take it. The test will be an hour and a half. Okay, so once you click start, you have an hour and a half to take it. So definitely start at an hour and a half before this time, before the ending time. And if you're wondering about when you can take it, I encourage you to take it during my office hours on Thursday, or I will also be on Zoom during my in-person CSCI 40 class. So that is 5:30 to 7 o'clock. During the time that they'll take the test, I'll also be there for you on Zoom, okay? So you can just yell at me and I can help you then as well, okay? So you have 2 options, either my Thursday office hours to come and take the test and ask questions, or my CSCI 40 in-person class. I'll be on Zoom and available then. Okay, so that is logistics. Here are the topics that the midterm will cover. So lectures through week 5, not including any of this stuff. The very last potential topic that I will go very easy on, if anything appears at all, are arrays and vectors. These iBook readings and Xilabs, and then labs 0 through 3. Okay, even though lab 3 won't be due, it's still going to be about loops, so it will behoove you to try it before you take the test, okay? So that you get more practice with loops when I release that. And so here's a list of topics that you should go over, things like that. And let's talk about the midterm itself now. So when you take it, you will have fill-in-the-blank and coding questions. So I want you to practice pasting code. Get ready to paste code into a Canvas text box, because that's how you're going to submit your exam. It's going to be on Canvas when you take it. Okay, so just get some experience copying and pasting code from wherever you are comfortable writing it. Okay, you can work on the server while you're taking the test. You can work in Visual Studio Code, whatever you want, but get a system down so that you're ready when you take the test. Okay, all the tests in my class are open book and open notes. I don't want you to memorize anything. That just seems useless, because when you're on the job, you won't have to do that. You can look everything up. But the one thing you can't do, of course, because it's a test, is talk to other humans, right? The only person you're allowed to talk to during the test is me, okay, to ask questions. And that's why I encourage you to take it during my office hours or during that class time, okay? So that is the format of the exam. That's what you can expect. And here are some sample questions. Here's the exam that I gave last semester. So you should expect to see very similar questions to those. So that will be great to study from. And then finally, I'm also releasing an extra credit assignment. Usually with every exam comes a new extra credit assignment. So this one is worth up to 2.5% extra credit and on top of your final grade. And what you can do is make a review video. This is a discussion so that your peers get to see the video that you post and love you forever for helping them study. So here's what I want you to do. So if you'd like to get this extra credit, make a video, record yourself. You don't have to edit it or anything. Just post the raw video and post a link to it. So you've got to do the following. Make a bunch of examples and go over them. The examples must have concepts that may appear on the exam, though. You can't just talk about something that we haven't learned about yet or never will learn in this class. So do that and just kind of pretend like you're me. Demonstrate what you're talking about, explain everything you're going over. Just pretend to be a teacher, maybe, okay? And then for your extra credit, I give you a time length limit. So if you want 1.25% extra credit, make a video of you talking about stuff and going over examples for 10 minutes. And if you want the full 2.5% extra credit, then make a 20-minute video, okay? So that is the extra credit assignment. I use OBS to record. I've used that and it works well. I can help you with it. You can also use Zoom and record yourself if you'd like. You can just make a Zoom call just with yourself in it and click record. That should also work. But I'd be happy to help you if you're having trouble or you need to like check out a laptop from the school. I can help you with any of that. I want to make sure that anybody who wants to do this can do it. Okay? So that's the extra credit assignment. It will be due the midnight before the exam is released. So that is going to be the 15th. Okay? That's the idea. So February 15th is the Tuesday because the exam is released on the Wednesday. So that is everything I think I want to say about your midterm 1. Good luck studying and let me know if you have any questions.